Pandas is an open source Python library. It is built on top of NumPy. Pandas has extensive functionality to read and write from various formats, such as CSV, JSON, Excel, etc., and also from various databases and HTML web pages, etc. And Pandas can integrate with the PyData ecosystem and work seamlessly with other Python data science libraries like Matplotlib, NumPy, scikit-learn, and other libraries. And you can install Pandas by using pip install pandas, or in case if you're using Anaconda distribution or any other Python distribution, most probably these data science libraries would have been installed by default. If not, please use conda and install these libraries. And this is an introduction video. And in this video, we will try to understand the basics of Pandas, and we will try to maybe load a data set and kind of use some of the functions which are available in Pandas, and we will use those methods and kind of slice and dice the data and try to understand along the way what are the Pandas features and functionalities. And to start off, Pandas has two primary data structures, series and DataFrame. And series is a one-dimensional labeled array capable of holding data of any type. That includes integers, strings, Python objects like dictionaries, etc. And data frame is a two-dimensional data structure with columns of potentially different types. That includes your columns could be numeric and mix and match of numeric and string, etc. And it is similar to, you can think of it as a spreadsheet or a SQL table. And also another way of thinking about a data frame is that each column in data frame is a series. Now that we have understood the basic data structures in Pandas, let us try to import a Pandas library. We can import the necessary libraries, but for now we'll just import Pandas as PD. That is a common convention, alias PD. So once we do that, we have our Pandas library in our environment. Next is we will create a series and a data frame. First, let me try to create a list, Python list. These are random numbers. I will store that in a variable data. Once I run this, I have the list ready. Next is it's pretty simple. I can use pd.series constructor, and I can start adding data to the series so that I can create the pd.series data structure. So like I said, this is a constructor for series class. So when you're calling it, you're creating a new instance of a Pandas series. So let me add the data here and maybe give a name. I will name it as series example, and I will store it in a variable s. And if I run this cell, I have my series. You can see automatically Pandas has given the index number as well. And let us try to create a data frame. And let me just copy and paste the code here to save time. I have used a dictionary. So this is the key. These are the values. I wanted 3 columns. So I will store that in data1 and run it. My dictionary is ready. So I can use pd.dataframe. And again, it's a class in Pandas library. When you call it, you're instantiating an object of that class, which results in the creation of a data frame. And as you can see, there are pretty number of arguments you can pass. But for now, we'll keep it simple. Store it in mydf, run this cell. My data frame is ready. So this is how you can create data frames and series objects in Pandas. And next is we will load a sample CSV data. It's on my local machine. So I can use a pd.read functions. If you know the type of data you're trying to bring in, based on that, you can use those Pandas read functions. In our case, we are going to use read CSV. And this also takes many arguments and file path and all the other arguments you see. Based on your requirement, you can use some of them. And in this case, we'll keep it simple. We'll just add the file path here. And let me add the file path. This is a sample data. So Let me make sure that the syntax is correct. And let me assign this to df, short for data frame. And if I run this, my sample data is ready. So once I have my sample data, I can do data exploration so that I can understand the data better. So as a first step, let me see how to use df.head. And once I use df.head, by default, it will return the top 5 rows. I can tweak that number. I can make it as 10, 15, 5, 3, or whatever based on my needs. In this case, let us try to bring in the top 3 rows. And as soon as I run that cell, I have my columns here. My index, zero-based index is on the left-hand side. I have all the values in each and every column. So pretty cool, right? So next is similar to head. We can also try to get the last rows by using the tail method. So instead of the default 5, you can tweak that code. For example, if I make it as -1, I don't want the first row, except that I want all the other rows. So that's how you use your slicing there. Let me make it as 3 here. I have the last 3 rows. So let's move forward with try to understand some more methods in Pandas library. So let us try to use the sample method. In case if you're working in data analytics, it's a cool idea to look at sample rows, right? Instead of top or bottom rows. So you can give a number there. Say, for example, I give 2. Those are 2 sample. Every time I run the cell, I get different samples. That way you'll understand the data better. So this is a pretty useful and handy method in Pandas. And next is I will use this attribute size. I want to see the size of my data frame. The size of the data frame is number of rows multiplied by number of columns if it is a data frame. As you can see here, we got 1.4 million total elements in our data frame. Next is we can use another attribute. We can use shape. I want to see how many rows and columns. And if I run this cell, I get my rows and columns, right? It's a data frame, so we get the rows first and columns next, as you can see there. And I have my shape and size, etc. And if you bring in data from elsewhere, in case if you want to store it in your local machine, you can use df.to, and to whatever format you want to, you can use those methods there. So it's also pretty handy in case if you want to store some of the data in your local machine as well. And next is we will try to look at say, for example, info. It's also pretty handy method. And once you run that, you get the structure of the data frame. That means you'll know the data types and what is the range index and what is the class. Like in this case, it's a data frame. You have your index, your columns, your if there are any null values, you will get the count there in the data types. And as you can see, it's a mixed data type, floats, integers, and objects. And also you have your memory size. So this is also pretty handy. And in case if you want to find out the data types, you can use df.data types so that you get all the data types available in your data frame. Next handy method is describe. It will give you the descriptive statistics. Let me run this. And once I run that, I get my descriptive statistics like count, mean, standard deviation, min, max, and percentile. So these are the numeric columns. So it gave me this. You can also run this on as object type of data types too. And next is, as we move along, let us try to read a particular column. So for example, I can use the square notation, and if I want to find out the minimum, I can use the min method as shown here, and I can swap out the min method to say max or count or mean or whatever. So instead of running a describe function, you can always use this kind of notation as well for each and every column. That also option is available. And next is we will try to get the top first row, and see you have your column names there and an index there, right? So let us try to say, for example, if there is no space in your column names, you can directly use the dot notation and bring in the column here. So for example, we'll say df.country. It's a single word. There is no space in the column name. You can always bring it like that. And also you can look at the columns by using df.columns, and you can save it. You can convert that into a list as well as shown here. So you have those options. So as you keep working in Pandas, you will try to understand more methods and properties and functions. So let me just bring in, say, for example, item type. I have to use the square notation. Within the square brackets, I have to enter the column name if there is a space or anything, right? So in case if you want to bring in multiple columns, all you have to do is in the inner square brackets, you have to add the list of columns as shown here, item type and total revenue. So you have your outer square brackets, just like in the previous cell, we could get our column. And in case if you have multiple columns, you can use the double square brackets so that you get the list of columns. So once we run that, we have the item type and total revenue. This is pretty cool. And in case if you want to, for example, if you want to see what is the total revenue, so let me just make sure that it is the correct column name, and you can use sum so that you get the total revenue there. So it's 133 billion or something. So individually you can run each and every method on those columns as well. So you have several flexible options available. So once you like I said, if you keep working on Pandas, you'll understand. Say for example, if I want to look at what are the countries, I can run df.country, and also I can run sample on an individual column as well. As shown here, I get say 3 samples on that individual column df.country. And say for example, another way to look at is say df.country equal to say Taiwan. So I can put this condition as well. I want to see the matching values whenever the country is Taiwan. I want to find out the rows. So this is how you use df square brackets followed by the condition. So you get all the rows with that matching condition. And let us try to expand that part. Let us try to say, for example, we'll see df region equal to, we will add Europe as a condition. And once we have that, we'll also think about other ways to look at the data. We will add df square brackets. That would be the first condition. And we will also can add total revenue. So for whenever region is Europe, we want to get the total revenue. This also can be done. So like I said, a lot of flexibility, and it looks a little bit complicated as of now, but I think as you keep working, you will try to understand all these functions in a better fashion. And this is another way. So you have multiple conditions here. Region, if the region is Europe and country is United Kingdom, and item type is snacks, so I want that matching condition. I want those rows only, so I can use this kind of multiple conditions within a df square brackets notation. So in case if I want total revenue, I can add that to the end so that I get the total revenue for those matching conditions. So this is flexible enough. This way you are exploring the data, you'll understand the data better so that you can create meaningful reports and meaningful way you can look at the data. So let me just look at the top 2 rows. And next is we will try to do data selection. So we will use df.loc and df.iloc. And when you're trying to use df.loc, you're accessing an instance of the loc indexer class. And once I do df.loc in the square brackets, we are passing the labels for row and column. In this case, this is the first row, so I'm getting all those values there. And I can keep finding out what type of object this is. If I wrap this around type function, we have understanding that it is a series. No wonder, right? So this is a series. So this is how you can keep selecting the data based on your needs. You can use .loc or another thing .iloc. I get there is subtle differences. .loc is label based, as we've already seen. Let me use some more examples here. And df.loc, say for example, if I type in 2 and region. So I will get this third row, right? Let me make it as 0 so that I get the first row. So region, and I want to find out what is the region, what is the value in the region column in the first row. That is how I got my value there. This is how you can use dfloc effectively. And if you want to retrieve all rows, this is how you do it. Df, and let me type it, df dot log square brackets colon. That means you want to retrieve all the rows, colon, comma, and you can add here, say for example, let me pick any of those columns. Let me pick order ID, and I'll get all the rows in that column. So this is how you get all the rows in that particular column, and you can retrieve all the rows. Let me maybe a couple of examples. Let me show you. So this is another example. Within that square brackets, you have this condition. You want those two things to be matching. Once I do that, I have this row. It could be more than one row too, but in my case, it is on one row. It is the result here based on that matching condition. So this is how you can use df.lock effectively. And this way you get index based. And let us try to look at some other thing. For example, if we want to return multiple columns, how can we do that? So let me just copy the code here. Let me just try to copy it here, or maybe type it here. df.log followed by square brackets. I want to retrieve all the rows, comma, and I can add the column here, region. And in case if I want to add more columns, I can add more columns as well. So within the square brackets, I'm adding the list of columns. That's what we have seen earlier, right? So it's pretty simple. In case if I want one column, I have one way of doing it. If I want multiple columns, I have to pass that as a list. So if I run this, I'll get all the rows, region, item type, and total revenue. And this is how you can do it. And if I run this, I get all those three columns, all the rows from those three columns. So you can make selections like that. And let us try to see df.log and df region. If region is not equal to, say for example, let us try to pick a region which we don't want to be shown in our result. Say we don't want any rows containing region Europe. So this is how you can do it. So this way you have different conditions. So based on your requirement, you can always bring the data like that and look at the data, make the data selections. And another thing is, like we said, iloc is an indexer used for integer location based indexing of DataFrame. And you can try to select specific rows and columns. You are going to give the indices, and it's pretty useful in data analytics too. So we have df.iloc. It looks similar, but again, this is a little bit subtle differences because you're using integer position here instead of basically a label based. And the 0 to 2 means last index position is ignored. So that means you get first and second rows. So when you want the integer based positions, you can use iloc. Otherwise, you can use loc. So in case if you want to select a single column, this is how you do it. We have already seen we want all the rows from second column. So you get all those rows from the second column. And also we want to look at the data frame again, df.head. So you have those top row here. Say there is a country column, right? So these are the country columns. So there is another method which is called as value counts method. So once you run this, you get values sorted in descending order, and all the NA and values, blank values, are ignored. So as shown here, Sudan 623, New Zealand 593, etc. And also a couple of quickly methods we'll look at. One is if you want to find out if there are any, what are the number of unique items in your data frame, you type in df.nUnique, and it will return all the unique values. And this is how you do it. And in case if you want to use unique method, if you want to find out unique values in a particular column, df.country in our case .unique will give you the unique number of elements in that particular column. So this wraps up our brief tour of Pandas Library. There is much more. We have just scratched the surface. Maybe at a future date, I will try to create more videos so that we can take a deep dive into Pandas Library and understand it better so that it will be useful in data analytics. So thanks for watching and see you in the next video.